This is top secret information, calling all students, parents and teachers. Your mission, should you choose to accept it, is to make as much money as you can for yourself by becoming a top maths DVD agent and spreading the word about the maths revision DVDs available from Top Grade Tutoring. Every time you refer a friend to buy any DVD from Top Grade Tutoring, you will in return gain a generous amount of commission that you can spend on whatever you like. To qualify, you must already have purchased a DVD. If you are under 16, you will be sent a parental consent form so that your parents or guardians give permission for you to become an agent. To apply for this exciting and rewarding mission, and for further information, simply go to www.topmathsdvd.co.uk/become an agent and make the first step to making money today. Good luck, Agent Top Maths DVD, and let's hope your mission is a success.
Welcome to the Top Grade Tutoring Maths Master Non-Calculator Skills DVD. My name is Stephen and I'm going to be presenting this. This DVD is for anybody between the ages of 11 to 16 who's looking to improve their non-calculator skills for non-calculator papers in both SAT and GCSE level exams. Although I'd love it to, this DVD is purely a reference guide and cannot be used as a replacement for lots of hard work and practice. The good thing about this DVD is that you can pause it, fast forward it, rewind it, as well as select each topic from the main menu as many times as you like if you don't get things first time. And let's face it, who does? I hope that you'll find this DVD of some use, and should you require any further information, then visit the Top Maths DVD website, that is www.topmathsdvd.co.uk. In this unit we will look at adding, subtracting, multiplying and dividing decimals. So let's start off by defining what exactly a decimal point is. Well, a decimal point is a bit like a fence in a number that separates the units from the tenths, hundredths, thousands, etc. So for example, if we take the decimal number 0.23, then this means 0 units, 2 tenths and 3 hundredths. So let's start off by adding two decimal numbers. So for this example, we will consider the decimal numbers 0.45 and 0.23. An important point to make is that when we're adding or subtracting, we have to make sure that we correctly align the columns. So for example, the units must go above the units, the tenths above the tenths, etc. So the procedure for adding and subtracting decimals is very similar to that of normal addition and subtraction. So we simply do 5 plus 3 to give 8, 4 plus 2 to give 6, we have to make sure the decimal point there is correctly aligned, and 0 plus 0 gives 0. So we get 0.68. Now let's try a more difficult example, 0.023 plus 0.4. So again we have to align the columns correctly, so 3 plus 0 gives 3, 2 plus 0 gives 2, 0 plus 4 gives 4, making sure there the decimal points are correctly aligned, and 0 plus 0 gives 0. So we end up with 0.423. Now for subtraction. Let's say we have 3.4 and we want to subtract 2.2. How will we do this? Again, we have to lay it out so that the columns are perfectly aligned, i.e. the units on top of the units, the tenths on top of the tenths, etc. So we're going to have a look at this example here, 3.4 minus 2.2. So we firstly have to lay it out so the tenths are in line with the tenths, decimal points are in line with each other, and the units are in line with each other. Then we just subtract in the usual way. So 4 take away 2 gives 2, 3 take away 2 gives 1. So we end up with 1.2. So now we're going to try a more difficult example. 3.662 minus 0.009. So here we align both the decimal numbers so that the units are in line with the units and the tenths in line with the tenths and so on. So we just subtract in the usual way. So 2 take away 9, well, we have to borrow 1 from the 6 here. So we cross that out, put 5, so that becomes 12 take away 9. And that, of course, is going to give 3. So now we've got 5 here. So 5 take away nothing, well, that's just going to be 5. 6 take away nothing, that's going to be 6. And 3 take away nothing, that's going to be 3. So we end up with 3.653. Okay, multiplying decimals now. So I'm going to introduce a new method to you called scaling, and this involves converting the decimal numbers into integers. So let's see how this is done with an example. So let's consider the following. 0.2 multiplied by 0.6. So we need to convert both 0.2 and 0.6 into integers by multiplying by 10, i.e. we scale them up to convert them to integers. So by multiplying both by 10 we get 2 and we get 6. So we need to multiply 2 by 6 to get 12. Now we need to divide this answer by 100. So we have to divide by 100 as we multiplied both 0.2 and 0.6 by 10. So 10 times 10 gives 100. So incidentally, when we divide by 100, we move the decimal point 2 places to the left. So we get 0.12. So the answer to 0.2 multiplied by 0.6 is equal to 0.12. So now let's consider a more difficult example. 0.002 multiplied by 0.3. So again, we have to convert both 0.002 and 0.3 into integers. So to convert 0.002 to an integer, we have to multiply by 1000, and to convert 0.3 to an integer, we have to multiply by 10. So when we do this, we get 2 and we get 3. So 2 times 3 gives 6. Now, as we multiplied 0.002 by 1000 and we multiplied 0.3 by 10, we have to divide the answer by 10,000. So we do 6 divided by 10,000. So this means we have to move the decimal point 4 places to the left. So we get 0.0006. So the answer to 0.002 multiplied by 0.3 is 0.0006. Multiplying an integer by a decimal. So let's say we wanted to multiply an integer by a decimal, for example, 3 multiplied by 0.2. So what will we do here? Well, we only need to scale 0.2 as 3 is already an integer. So we multiply 0.2 by 10 to get 2. Now we do 2 times 3, which equals 6, and then we divide 6 by 10 as we originally multiplied by 10. So 6 divided by 10 is equal to 0.6. Hence our final answer to the problem 3 times 0.2 is equal to 0.6. Now let's try a harder example. 0.005 multiplied by 4. Okay, so here we need to convert 0.005 into an integer. So we multiply it by 1000. So now we have 5 times 4, which equals 20. So now we need to do 20 divided by 1000, which equals 0.020, as we originally multiplied 0.05 by 1000, hence we have to divide by 1000. So the final answer to the problem 0.005 multiplied by 4 is 0.020. Now let's consider decimal division. Again, we have to use the principle of scaling the decimal numbers by multiplying by a given power of 10. So let us consider the following. 0.20 divided by 0.10. Now in order to solve this, we have to multiply both 0.20 and 0.10 by 10 to convert them to integers. An important point to note here is that unlike with decimal multiplication, what we do to one side we must also do to the other side to keep everything in proportion. So by multiplying 0.20 and 0.10 by 10, we get 2 and 1. Now we can do this simple piece of division, 2 divided by 1, which equals 2. Unlike decimal multiplication, we don't have to do anything further. We have arrived at the answer, which is 2, as the same amount of 0.10s will go into 0.20s as 1s will go into 2. So let's now consider a more difficult example. 1.8 divided by 0.06. Now we need to convert both decimals into integers, but remember what we do to one side, we must also do to the other. So to convert 0.06 into an integer, we must multiply this by 100 to get 6. And as we have done that to 0.06, we also have to multiply 1.8 by 100 to get 180. So we are now left with 180 divided by 6, which equals 30. So the final answer to 1.8 divided by 0.06 is 30. Okay, so let's look at dividing a decimal number by an integer. So in this example we will do 7.26 divided by 3. So to do this we lay it out as if we were doing a normal long division problem. Now we solve it in the usual way, starting off with 3 into 7, which is going to go twice, with a remainder of 1 which we carry across. We then do 3 into 12, which goes 4 times, and then finally 3 into 6, which goes twice. Now an important point to make here is that we have to ensure that the decimal points are correctly aligned, i.e. directly above one another. Now let's look at an example that may appear in an exam. A man cycles around a track 3 times and in total travels a distance of 25.8 kilometers. Calculate the length of the track. We need to find out the distance around the track once. We already know the distance around the track 3 times around, so we take this distance, i.e. 25.8 kilometers, and divide it by 3. So again we just lay it out as if we were doing a normal long division problem. Again remembering to correctly align the decimal points. So we do 3 into 25, which is going to go 8 times, with a remainder of 1 which we carry across. Then we do 3 into 18, which is going to go 6 times exactly. So again we make sure that the decimal points are correctly aligned, so we end up with 8.6. So the distance around the track once is 8.6 kilometers. Okay, so time for percentages now. So just going to start off by recapping on what percentages are. Well, a percentage is simply a fraction written out of 100. So for example, 1% is 1 out of 100, and 10% is 10 out of 100, which incidentally simplifies to 1/10. So to find a percentage of an amount, finding 10% is a good starting point, particularly with VAT calculations, as we will see a little bit later on. So then, let's say we wanted to find 15% of 260. How will we do this? Well, 15% is 10% plus 5%. So we start off by finding 10% of 260. So 10% is 10 out of 100, which simplifies to 1/10. So whenever we find 10% of something, we just divide by 10. So 10% of 260 is going to be 26. So 260 divided by 10, just move the decimal point 1 to the left there to give us 26. Now we need to find 5% of 260. Well, as 5% is half of 10%, we simply divide the result that we obtained in step 1 by 2. So we just take 26 there and divide it by 2 to get 13. So 5% of 260 is equal to 13. Now, as 15% is equal to 10% plus 5%, we simply add the two results that we got earlier. So we do 26 plus 13, which equals 39. So that's it, we've done it. 15% of 260 is equal to 39. So let's try a harder example now. Let's find 75% of 760. Well, 75% is 7 lots of 10% plus 5%. So we start off by finding 10% of 760, which is 760 divided by 10, which equals 76. Now we need to find 5% of 760. So we simply divide 76 by 2, as 76 is 10% of 760. So 5% is half as much as that. So 76 divided by 2, that gives us 38. So the final step now is to multiply 10% by 7. So that's 7 times 76. Then we add the 5%, which is 38. So we get 532 plus 38, which equals 570. Okay, let's look at calculating VAT. Let's say we wanted to find the VAT on a television costing £300. How would we do this? Well, VAT is currently 17.5%. So we can break that down and say that 17.5% is equal to 10% plus 5% plus 2.5%. Well, 10% of £300 is going to be 30. So we just divide 300 by 10 there to get 30. So 5% of £300, well, that's going to be half as much as 10%. So that's £30 divided by 2 to give £15. And 2.5% of 300, well, that's just going to be half as much as 5%. So we take £15 and divide it by 2 to get £7.50. So 17.5% is going to be 10% plus 5% plus 2.5%. So that's £30 plus £15 plus £7.50. So we get £52.50. So let's look at percentage increase and decrease now. So let's say we want to increase 150 by 25%. Well, 25% is two lots of 10% plus 5%. So 10% of 150 is going to be 150 divided by 10, which gives 15. So 5% is going to be half as much as 10%, so that's 15 divided by 2 to give 7.5. So therefore 25% is going to be two lots of 10% plus 5%, so that's 2 times 15 plus 7.5, which equals 37.5. So now we need to add 37.5 to 150 to get 187.5. So let's do an example of decreasing by a given percentage. So let's look at decreasing 200 by 15%. Well, 15% is 10% plus 5%. So 10% of 200 is going to be 200 divided by 10, which equals 20. And 5% of 200 is going to be 10% of it divided by 2, so that's 20 divided by 2, which gives 10. So 15% is 10% plus 5%, so that's 20 plus 10, which gives 30. So now we need to subtract 30 from 200, which is going to give 170 to give our final answer there. What we hope to do in this unit is to find out how to find fractions of amounts, simplify fractions, add, subtract, divide and multiply fractions. Finally, we'll then look at improper and mixed fractions and learn how to convert from one to the other. So let's say we wanted to do the following: 1/2 plus a third. So the key to solving this problem is to firstly find the LCM of both the denominators 2 and 3, i.e. the lowest common multiple. Another way to think of this is the smallest number that both 2 and 3 will go into. So in this case it will be 6. Now we need to convert both fractions so that the denominator is 6 for both fractions. So to do this we need to multiply the numerator and the denominator of the first fraction by 3. The reason that we multiply both top and bottom of the first fraction by 3 is as the denominator of the first fraction 2 goes into 6 exactly 3 times. Then we multiply the numerator and denominator of the second fraction by 2, as the denominator of the second fraction goes into 6 exactly 2 times. So now, after we've converted the fractions, we simply add the two numerators together and we get 5/6. So let's look at multiplying fractions now. So multiplying fractions is very straightforward and simply consists of multiplying across, i.e. multiplying the two numerators together and multiplying the two denominators together. So let's consider an example. 1/4 multiplied by 3/6. So here we simply multiply the two top numerators together to get 3 and the two denominators together to get 24. So we end up with 3 over 24. Now this fraction can be simplified by dividing both the top and the bottom by 3. So the final answer is 1/8. Okay, so let's look at subtracting fractions now. So the procedure for subtracting fractions is basically the same as adding fractions, although once we have converted the fractions to have the same denominator, instead of adding the numerators, we subtract them. So let's consider an example, 5/6 minus a third. So the first step is to find the lowest common multiple of 6 and 3, which is going to be 6. And the second step is to rewrite both fractions in terms of the LCM. So the 5/6 here is unchanged as the denominator is already 6. The 1/3 becomes 2/6 as 3 goes into 6 twice, so we have to multiply both the numerator and the denominator by 2 to get 2/6. So once we've converted a third into 2/6, we just simply subtract the numerators. So 5/6 minus 2/6 equals 3/6, which simplifies to a half. Dividing fractions is very similar to multiplying fractions, the only difference being that we turn the divide sign into a multiplication sign and we invert the second fraction. That is to say that we turn it upside down. So let's have a look at an example. So 2/3 divided by 1/6. So what we do here, we turn the divide into a multiplication and we invert the second fraction. So we get 2/3 multiplied by 6/1. So multiplying the two top numbers together, we get 12, and multiplying the two bottom numbers together, we get 3. So we end up with 12/3, which equals 4. So now let's look at mixed fractions and improper fractions. An improper fraction or top-heavy fraction is where the number on the top is bigger than the number on the bottom. So for example, 5/3. A mixed fraction or mixed number, as it is sometimes called, is where you have a number with a fraction part. So for example, 2.5. Now let's look at converting an improper fraction to a mixed fraction. Converting an improper fraction to a mixed fraction is relatively straightforward. All you have to do is find out how many times the denominator goes into the numerator of the fraction, then write this number down and express the remainder as a fraction of the denominator. So for example, if we take 5/3, 3 goes into 5 once with a remainder of 2. So the mixed fraction that this is equal to would be 1 2/3. Now let's look at converting mixed fractions into improper fractions. So if we had 1 3/4, what would this be as an improper fraction? Well, to find out, all we need to do is to multiply the integer part, in this case 1, by the denominator part of the fraction, which is 4. We then add this to the numerator of the fraction, which in this example is 3. So when you total this up, we get 7 for this example. Now we express this value as a fraction, with the denominator of the fraction being the same as the denominator of the fraction part of the mixed fraction, which in this example is 4. So the final answer is 7/4. Now let's look at adding, subtracting, multiplying and dividing mixed fractions. So the procedure for either adding, subtracting, multiplying or dividing mixed fractions is simple. Firstly, convert the mixed fraction into an improper fraction, then apply the usual procedure depending upon the operation that you are performing, i.e. addition, subtraction, multiplication or division. So for example, let's say we wanted to calculate 2.5 multiplied by 3 1/4. So the first step would be to convert both 2.5 and 3 1/4 into improper fractions. So 2.5 would become 5/2 and 3 1/4 will become 13/4. The second step is just to multiply the fractions in the usual way as described previously. So you multiply the two numerators together and the two denominators together. So 5 times 13 gives 65 and 2 times 4 gives 8. So we're left with 65/8. So this can be simplified to 8 1/8. So if we were presented with two fractions to add, subtract or divide, we would again convert the fractions into improper fractions, then apply the respective procedures outlined earlier on. So if you're unsure of these procedures, rewind to the section on adding, subtracting, dividing and multiplying. But remember, you must convert to an improper fraction first. Okay, let's look at finding fractions of amounts. So let's say that we wanted to find 3/4 of 200 without using a calculator. How can we do this? Well, the easiest way to tackle this is to do 200 divided by 4, which equals 50, then to do 50 multiplied by 3, which equals 150. So the rule is divide the number that you want to find the fraction of by the denominator of the fraction and then multiply this value by the numerator of the fraction. In this section we will look at ratios, long multiplication using the grid method and division using the multiples method. We will also look at calculations involving numbers in standard form. Okay, let's start off with ratios then. Well, a ratio is simply one quantity expressed in terms of another quantity. For example, in a classroom, for every one boy that there are two girls, and this is expressed as 1 to 2. We can also think of a ratio in terms of parts. So for the example of the boys and girls in the classroom, we can say that there is 1 part to 2 parts. So there are a total of 3 parts. So we can say that in the classroom, 1/3 are boys and 2/3 are girls. So a typical non-calculated question may be as follows. The ratio of boys to girls in a classroom is 1 to 2. If there are 20 girls, how many boys are there? Also, how many children are there in the classroom in total? Well, we're told that there are 20 girls. The girls represent 2 parts in the ratio, so 2 parts equals 20. So 1 part can be calculated by doing 20 divided by 2, which equals 10. The boys part of the ratio represents 1 part. So then we can say that there are 10 boys in the classroom. Now that we know that there are 20 girls in a classroom and 10 boys, it's easy to see that there are 30 children in total. Now let's look at a more difficult example. It takes 20 builders 30 days to complete building a house. How long would it take 40 builders? Well, if it takes 20 builders 30 days, increasing the number of builders will reduce the amount of time it takes to build the house. So the solution here is that we have to multiply the number of days it takes by a half, i.e. decrease it in the ratio 20 to 40, which cancels down to 1 to 2. So by multiplying 30 by a half, we get 15 days, which makes logical sense, as if we're doubling the number of people working on a project, then it will halve the amount of time it will take to complete. Let's look at long multiplication now. So the grid method is an excellent way to perform long multiplication. It is a method that is currently taught in the majority of primary schools in the UK as part of the numeracy curriculum, but has applications for both Key Stage 3, Key Stage 4 levels and beyond, which is why I think it's such a fantastic method. So let's say that we wanted to do 234 multiplied by 14. How can we do this? Well, the solution lies in constructing a grid. We break up each number into its constituent parts, i.e. hundreds, tens and units, and align them along the grid. So for example, running along the top of the grid we would have 200, 30 and 4. Then running down the vertical side of the grid we would have 10 and 4. Then we take 10 and multiply it by 200, 30 and then 4. After that we do the same with 4 and again multiply it by 200, 30 and 4. We add up the totals of the rows and this gives us the answer to the original problem. So here we've constructed the grid, so just go over this again. So we do 10 times 200 which gives 2000, 10 times 30 which gives 300, 10 times 4 which gives 40. So we do 2000 plus 300 plus 40 which gives 2340, 4 times 200 which gives 800, 4 times 30 which gives 120, 4 4 16, so we do 800 plus 120 plus 16 which gives 936, so we do 2340 plus 936 which gives 3276, which is our answer to the initial problem, 234 multiplied by 14. Okay, so we're going to look at standard form now. So if we were presented with the following standard form question in a non-calculator paper, then how would we deal with it? 1.2 times 10 cubed divided by 0.6 times 10 squared. Well, the solution is to firstly scale up both 1.2 and 0.6. So we need to multiply both of them by 10 to get 12 and 6. Then we do 12 divided by 6 to give 2. And the second step involves taking 10 cubed and 10 squared and dividing the 2. So by the laws of indices we simply subtract the powers, i.e. 3 take away 2 to get 1, so it's going to be 10 to the power 1, or just simply 10. And the final step involves combining the results from step 1 and step 2. So we get the following answer, 2 times 10 to the power 1, which is simply going to be 20. So that's the final answer. So 1.2 times 10 cubed divided by 0.6 times 10 squared is equal to 20. Now let's take a look at long division. So let's say that we wanted to do 6071 divided by 13. How would we do this? Well, I'm going to introduce to you a method now which involves listing multiples of a dividing number. So without further ado, let's take a look at how we would do this. So the first step to solving 6071 is to list the multiples of 13 up to a sensible number. So for this example, I've chosen 117. So the multiples of 13 up to 117 are 13, 26, 39, 52, 65, 78, 91, 104 and 117. So the second step involves performing the division in the usual way using the multiples to help. Right, so we do 13 into 6, well that's not going to go. So we do 13 into 60. Now looking at the list of multiples, the closest number that we can get to 60 is going to be 52. So that goes in 4 times, as 52 is 4th on the list. So put the 4 on the top there. Now we've got a remainder there of 8. So we carry the 8 across there. So we then do 13 into 87. Well, the closest number we can get to 87 is going to be 78. So that's 1, 2, 3, 4, 5, 6 on the list. So we put 6 on the top here. Now we've got a remainder there of 9. So we bring the 9 over to here by the 1 and then do 13 into 91. Well, 91 is on the list of multiples of 13. It's 1, 2, 3, 4, 5, 6, 7th on the list. So it goes in exactly without any remainder. So we put the 7 on the top here. So we've done it. So 6071 divided by 13 is going to equal 467. So that's how we do long division using the multiples method. Okay, time for some top hints and tips to help maximise your marks in the exam. The first tip is to show all of your working out in the exam. If you don't, then you will get a maximum of 1 mark. That's if there is more than 1 mark awarded for the question. Also ensure that your work is legible, so that the person marking your paper can read your work. Remember, examiners are busy people and do not have time to try and interpret your work. Remember, if they can't read your work, you may not get any marks at all. The second tip is to leave plenty of time for revision. I cannot stress enough that plenty of exam revision and practice of past exam papers is vital to exam success. Practice papers are often available from your school or college, from the internet, or from exam boards directly. The third tip is to practice your times tables. Although it may seem obvious, knowing your times tables is very important, as a degree of basic mental arithmetic is expected from non-calculator papers at both SATs and GCSE level exams. Non-calculator questions can sometimes involve 2 or even 3-step word problems. The fourth tip therefore is to make sure that you are able to understand what the questions are asking and able to extract the various calculations that are required from the question. This can only come with practice of past exam papers. Finally, an additional tip is to try not to get into conversation with your peers after the exam, as often the non-calculator paper is the first paper that you will do. Any worry that you may have regarding the answers that you put down may inhibit your focus for the second paper. All that remains to be said now is good luck for the exam. Remember, if you do require revision for calculator papers, there are other DVDs in the series. For more information, please visit the Top Maths DVD website. That is www.topmathsdvd.co.uk.